Okay, so 11.5, which will mark the last section that you will learn this year, is the area. It's called the area problem, but it has two topics. It has summation and it has the area problem, both things that you will see again next year. So these formulas, you actually, if you took Algebra 2 honors here, we actually talked about these formulas, but briefly. These formulas are like shortcuts to doing summation. Summation means like you're adding up the terms inside of a series. So like if I had in that little letter, that little E is called sigma, okay? Having nothing to do with why does everybody giggle? Having nothing to do with sigma that you guys know. This is summation, okay? It is just a Greek letter. But let's say it said this and then it said n plus 5, okay? Let's say like just simple, something like that. Then one way to do this, and the long way to do this, is I would take and plug in 1, then plug in 2, then plug in 3, then plug in 4, then plug in 5, then plug in 6, 7, 8, 9, 10, and then add all those terms together. So if it's only like 3 terms, that's not so bad. But obviously the bigger the number on the top, the more waste of time that is. So in arithmetic and geometric sequences, there are shortcuts to finding those things. But in any other sequence, you can use these shortcuts. So what we're going to do is we're going to take our summations and we're going to break them apart so they are single terms. And then we're going to use these shortcuts to add them all up. So if I had just a number next to it, let's say it said I equals 1, and let's say it said 10 on top, and it said 5 here, then there would be no plugging in involved, but I'd have to do 10 terms of 5. So the shortcut here is to simply multiply the number next to it times the number at the top. So the number at the top is the number of terms if the bottom number is 1, which all of these will have a bottom number of 1. And so this would literally be 5 times 10 or 50 if it's just a constant. If it's just a variable, so now let's say it said I equals 1 and 10, and this said I here, then I can use this formula. N, which is 10 in this case, times 10 plus 1 all over 2. And then I would simplify that. If it said a variable squared, so starting with the same, this would be I squared, then I would use this formula, which would be 10 times 10 plus 1 times 2 times 10 plus 1 all over 6. If it was cubed, it would follow this pattern, so it would be 10 squared times 10 plus 1 squared over 4. If it was a sum or difference, so if it said 2 plus 3i, something like that, then the first thing we're going to do, actually, let me just make that I first. 2 plus I. Then the first thing we're going to do is break that apart so that it would be the sum of 2 plus the sum of I. And then we would fall back on those earlier rules. If it's just a constant, we would do the first thing. And if it's just a variable, we would do the second thing. So you're going to break them apart. And then the last one is if there's a coefficient on your variable. And for that, we bump it to the front, almost like what we do with a log. And we would multiply it at the end. So that would be something like this, maybe 3i. So the 3 would get bumped to the front. I'd use the rules of just a single variable to find the summation of I, and then I would multiply that times 3. So this, to me, like, is one of those things that it seems like a lot in the beginning, but once you get the hang of it, it's actually quite easy, and your calculator does most of the work. You're literally just figuring out which formula am I using. So again, every first step will be break it apart. Then use your individual summation rules. This little box is on your homework. Like if I were to give you a quiz on this, I would have given you the box. I don't know that Ms. Ferrier does that, but we're going to at least do that. That's next year's problem. I put it on the homework so that you can kind of like pull it in right there. All right, so example 1. Evaluate the sum using summation formulas and properties. So I'm going to look at A, and I'll pull in the formulas so they're right here with us, okay? If you look at A, this is the summation from 1 to 20 of I squared. So I squared means I would grab the I squared formula, which is n times n plus 1 times 2n plus 1 all over 6. And then again, if the bottom number is 1, which it will be in all of these, then the top number is your n. So this becomes 20 times 20 plus 1 times 2 times 20 plus 1 all over 6. And you could type that whole thing in your calculator. You could simplify it if you wanted to. You could type it in as 20 times 21 times 41 over 6. It doesn't matter how you type that in. Okay, but then you get your summation, which should be 20 times 21 times 41 divided by 6. 2,870. Okay. Which is obviously faster than plugging in 1 and squaring it, then 2 and squaring it, then 3 and squaring it, then 4, and then all the way up to 20, and then having to add all those numbers together. Questions on that one? All right, B has a coefficient on the variable, so we bump the coefficient to the front. So I don't write the I equals 1 and the 31 every time. I just do the sigma to remind me that I'm gonna add them. So I separate it that way. I know I have to do sigma I, so this is a single variable, and that's the second formula, n times n plus 1 over 2. And n this time is what? 31. So this is 2 times 31 times 32 over 2. You can simplify that, like you could cross out your 2's and all you have to type in your calculator is 31 times 32. Or you could type that whole thing in. Either way, you should get 992. Good so far? Yes? All right, example 2, and A and B just continue. So this is I squared minus 3I. Now we have a sum or a difference. So the first thing you want to do is separate it out. So I would do the summation of I squared minus the summation of 3I. So separate it out first. Then bump the coefficient. So the 3 goes to the front of just that summation part. So it's I squared minus 3 times the sum of I. And now we do the individual equations. I squared is n times n plus 1 times 2n plus 1 over 6 minus 3 times n plus 1 over 2.
Wait, what's the formulas for next?
Yeah, because this one's raised to the second power and this one's raised to the first. Yep. What's n this time? 21. So it's 21 times 21 plus 1, or 22, times 21 times 2, 41 plus 1, 42, over 6, minus 3 times 21 times 22 over 2. And you don't have to simplify it. Like maybe if you're doing mental math, like if it was a test, I would obviously make sure I check that really quick, carefully, because you don't want to cause an error from trying to do your mental math. You could just do this whole 22.
Do we have to be doing these?
Oops. They're not, these are not going to take.
Yeah, isn't it 43?
42, yes, thank you. 42 plus 1. I did that on purpose to show how important it is to check your work and not do the, yeah. 21 times 22 times 43 divided by 6 is 3,311. 3 times 21 times 22 divided by 2 is 693. And then 3,311 minus 693. 2,618.
Do you recommend writing it all out?
I mean, honestly, it depends on the calculator I have. If I have the graphing utility and you can type that whole thing in, then no. But if it's scientific and if you need to break it apart, then yes. Okay, B, we're going to break it apart. 2I plus 9, 2 bumps to the front. 2 times the summation of I plus the summation of 9. The I becomes n times n plus 1 over 2. And the 9 we just multiply times the n. So 9 times n. And the n this time is 32. 32 times 32 plus 1, 33 over 2. Because the 2 bumped for the front. This is that 2. Again, you could cancel out your 2's so it's less typing, or you could multiply it in. It doesn't matter. So 1056 plus 288. 1344. All right, now I'm going to teach you how to do it with your graphing calculator. Okay, so summation falls under the math menu. If you go to math, you don't see it because it's the next one. It's like the 10th thing in the row, so it's 0. That's summation. And then our variable is n, but we just use x as our variable. I do x, math, and 0. So the next thing after what you see. Yeah. And then x equals 1. Again, it doesn't matter because it's just a variable. X or I is same difference. Then 32 at top. And then next to it, 2x plus 9, enter. Literally type it. So if it was squared, I would do I squared, whatever it is. So if I went back to the other one, math.
So I'm confused. Will they not?
No, you can't do this for the homework. That defeats the whole purpose.
Because you need a
20.
calculator for this.
Yeah, but they would give you scientific.
There's a scientific and a normal, non-scientific.
No, I'm not talking about your AP exam. That would be the first one. I'm talking about like if she was going to assess you.
So like,
You technically would not need a calculator if the numbers were smaller. All right, example 3 says rewrite the sum as a rational function and then find the limit as it approaches. Actually, we're totally skipping this one. Yep. All right, area of the curve. So you are going to get asked to find the area of shapes that are not like geometric shapes. It's not going to be a rectangle or triangle or a hexagon, something that you could find the area forming using formulas you already know. What will happen, and this is like also a topic that like gets reapplied in so many different ways in calc, but you are going to, and there's 2 ways to do this kind of question. One is to approximate the area. So this is not an exact area. We are going to approximate the area by literally drawing rectangles underneath our curve. So depending on, and we'll see this a couple different ways, these questions that I'm giving you now will already have the rectangles drawn. Okay, at some point you will need to learn how to do that, but that is Miss Ferrier's problem, not mine. Okay, so these you are going to literally look at all those little purple rectangles, and they're usually purple, like on Webasine I think they're also purple. And you're going to pay attention to the length and the width of each of these because that's how you find area of a rectangle, right? And then we're going to add them all together. So the first thing I'm going to do is figure out the width because the width is the easiest thing because it's consistent across these, right? So if you look at the bottom, I'm going to go from 0 to 2, right? And then how many rectangles are there in this case? 5. So if I wanted to know what the width of each of them were, what would I do? Divide 2 by 5. So the width of each of those is going to be 2 by 5. I mean 2 over 5, not 2 by 5. With me so far? Now to find the height of each of these, I'm going to use the equation that they give you. So they tell me that this curve is 6 minus x squared, okay? We're only using a portion of it because that would be a full parabola, but we're using a portion of it. So if I wanted to know, let's just say I start with this first rectangle. Okay? The width we said was 2/5. If I want to know the height of it, I'm going to the point where my rectangle hits my curve. How would I know the height of that point? How could I find the y coordinate of that?
Plug in the value 2 over 5.
Good. I'm going to plug in my x value. So I'm doing f of 2 over 5. And then we're going to work it out on the next screen. I'm just going to set it up here. And then if I go to the next one, I want to find that height. Now what's my x value? I went from 2 over 5 to the right, 2 over 5, right? So 2 over 5 plus 2 over 5, which would be 4 over 5. And then I'm going to go over, again, another 2/5. So this would be 6/5. And then I'm going to go over again, another 2/5. and it's going to be 8/5. And then the last one would be 10/5, which is 2, okay? So in order to find the width, we take the actual marked points. We divide by the number of rectangles that are there. To find the height, you have to find f of whatever the value is at that x coordinate. So if there is 5 triangles, you're going to do this 5 rectangles, you're going to do this 5 times. If there was 4 rectangles, you're going to do it 4 times. And then at the end, you're literally going to add them all together. All right, so let's walk through it. It's the same picture, so kind of already started it. But the directions say use the 5 rectangles to approximate the area of the region bounded by the graph of the function, considering the x-axis, or the region bounded by the graph, the x-axis, and the lines x equals 0 and x equals 2. So that's where I know I'm starting and stopping. So it would be the same. 2 divided by 5 is going to be my width. There are 5 boxes. So if you literally want to give yourself 5 boxes to remind yourself you're adding up 5 areas, you can. Each one is going to have length times width. And we already know the width of each of them is 2/5. Now we got to find the height. So we're doing f of 2/5. And then we're going to add 2/5 to it because that would be the next x value, which we said was 4/5. And then we said that's 6/5. And then we said that's 8/5. And then we said that's 2. Now you have your calculators, right? So if you remember how to just make this your y equals, then we can just plug them each in individually. So I'm going to make my y 6 minus x squared. You can just type them in every time, but I think this is easier. And you guys are certainly more comfortable doing this now. And then you can either go to the graph and type in the value for each one, or you could do your alpha calc y1 and do 2/5. And I get 5.84. And then repeat it, y1 4/5. And I get 5.36. And I do 6/5. And I get 4.56. And I do 8/5. And I get 3.44. And I can do 10/5 or 2. And I get 2. So again, individually I could have done 6 minus 2/5 squared, or 6 minus 4, and then 6 minus 4/5 squared, and then 6 minus 6/5, like that. Or you could type that in as your y equation and then find f of 2/5, or y1 of 2/5, y1 of 4/5, like that. And then I am multiplying each of these out to get the area of the original ones, of each separate one, okay? You can do this 2 ways. You can multiply each of those out and then add them all together at the end. Or because we're multiplying by 2/5, we can pull out the 2/5, add up all of these, and then multiply by 2/5 at the end. You could do it either way. So again, I can either do 2/5, interesting, 0.4 times 5.84 and get this area, 2.336. 0.4 times 5.36. 2.144. 0.4 times 4.56, 1.824. 0.4 times 3.44, 1.376. And 0.4 times 2, 0.8. And then I can add all those together. 2.336, 2.144, 1.824, 1.376, 0.8. And I get 8.48. Or I could have just added all of the heights together. 5.84, 5.36, 4.56, 3.44, and 2. And multiply that sum times the 2/5. So same answer. And this is obviously not an exact area. This is an approximation. Tedious, but not terrible, right? Questions? I cannot wait to be done with this stuff. Yeah, okay. All right, you try this one. All right, so we're going from 0 to 2 this time again, but how many rectangles are there? 4. So what's going to be the width of each of these? A half. So this is a half, then it would go to 1, then it would go to 3 halves, or 1.5. Obviously, you have your calculators, so your decimals might be easier here. So then if I wanted to find the height of each one, I'm going to do f of 0.5, and then I'm going to do f of 1, and then I'm going to do f of 1.5, and then I'm going to do f of 2. And this time it's just x plus 1. So this is 1.5, this is 2, this is 3.5, no, 2.5, sorry. 2.5, and this is 3. And then the width for each of these is a half. So you can either add these all up and then multiply by a half, or I could do them individually and add them up. So 1.5, I'm just going to add them all up first. 2, 2.5, 3, which is 9, times a half is 4.5. Questions? Okay, in the homework there is one that looks like this. Now notice that part of these rectangles are outside my curve and part of them are inside the curve. When you're marking which lines you're going to use for your height, you will start with the one that is touching the curve. So this one goes beyond the curve. I don't do f of -1. I go to the one in which it starts by touching the curve. So this is going to be the first x I do, -1.5 or 0.5. Then I do f of 0, then I do f of 0.5, and then I do f of 1. So if it's under the curve, you're looking for where it touches the curve, which is what we've done up to this point. If it's over the curve, you can't use this one. You go to the first time it hits the curve. Does that make sense? The first time it literally has a point that overlaps with the curve itself. So that point is tangent to the curve. So I would do f of -0.5, f of 0, f of 0.5, and f of 1. I would not do f of -1, okay? Does that make sense? So if it goes outside, don't use that one. If it's taller than the curve, don't use that one. Go to the first time it touches the curve. Okay, we will not do this, okay? But this is a more accurate way to find, which you will do this next year. This is a more accurate way to find the approximation of the area, and it is using summation. So in this case, you need an A and a B. An A is where you start your point. So like if we did 0 to 2, it's 0 to 2. The A is 0, the B is 2. And then we use summation to find the condensed version of that. And then you find the limit as it approaches infinity. So you use the rules of horizontal asymptotes and all that stuff. So you would literally take your A and your B, you would plug it in, and then you go through all these steps. You would do summation of them. You would get one equation because you're not plugging in a number, you're keeping n as n. And then you would use the rules that we talked about in 11.4. But we're not going to worry about this. We're going to let Miss Ferrier worry about it. Okay? We're stopping with the area under the curve. Questions? Okay.